We're gonna see our first video of the day. It's nice to be able to see a video format, which is new to our virtual forum, and I hope you guys all enjoy the show from Amalgamated Vision and the Q&A to follow.
Hello. Every day we hear about the coming digital data revolution that will change the way we live. Extended reality and spatial computing will enhance our lives by making information more available and easier to understand. 7 years ago, Google Glass was released. Since then, tech companies have spent billions of dollars in the development of head-mounted display. Today, anyone can buy these products. So let me ask you, how many viewers at a NASA technology conference are watching this presentation wearing head-mounted display? I would be surprised if anyone is wearing smart glasses. So, why is this happening? When it comes right down to it, the single most important factor holding back widespread acceptance is the eyewear itself. Headsets are bulky and ugly. My 21-year-old daughters would not be caught dead wearing one. The resolution is poor, and despite what you've seen in the media, digital data in front of your eyes can be distracting and annoying. My name is Adam Davis. I am a neuroradiologist and the founder of Amalgamated Vision. We are an optical design company dedicated to creating portable personal head-mounted display, and I believe we have found a better solution. 20 years ago, I authored a paper describing the use of 3D stereoscopic imaging to guide medical therapy. It required low-profile, high-resolution display that would allow physicians to work with their hands and interact with their environment as easily and naturally as if they wore no headset at all. Virtual retinal display was identified as the best technology to satisfy these requirements. Using laser MEMS technology, the image is painted directly onto the retina of the eye. There is no display screen. Over the past decade, Amalgamated Vision created an optical engine that provides high resolution, brilliant luminescence, deep color saturation, and a wide field of view. Our compact size enables a look-down form factor that does not obscure the user's normal vision. It is ultra-near to eye, it rests comfortably on the face, and it is 3D stereoscopic. Laser light is safe for prolonged use. Like any light source, it simply needs to be applied correctly. Our technology can serve all mobile display platforms. The addition of pass-through video allows for mixed reality. To understand why our technology is so radically different from other eyewear, we need to take a closer look at the optics. Our paradigm depends on the ability to take the light output of a laser projector and squeeze it through the pupil of the eye onto the retina. This is not a trivial task. It has been an obstacle to the use of this technology despite laser light's inherent advantages: high energy efficiency, deep color saturation, and extreme luminescence. AV has developed the technology needed to overcome the two critical problems: a small field of view and a small exit pupil. Let me explain. Some manufacturers using laser light projection rely on a type of optics called a combiner or birdbath configuration. By reflecting the light on a curved surface, it allows the display to be superimposed on the real-world view with good resolution and a wide field of view. This optical solution is particularly prominent in the aerospace applications, but the large size and poor ergonomics for mobile display are obvious. Consequently, nearly all products today use a waveguide solution. Waveguides are complicated, but simply put, they propagate light via total internal reflection and then periodically let the light escape across a wide viewing area. But waveguide physics degrade the resolution of the light source, and their materials obscure the real-world view. Most are neither compact nor appropriate for everyday mobility. In see-through augmented reality, the digital display itself distracts from the subject of the viewer's concern. In these two images, we see an anesthesiologist looking out over the surgical field and an EMT leaning over a patient. In both cases, the subject of interest is obscured. Contact lenses for augmented reality have been in development for over a decade, with or without accompanying eyewear. Contact lenslets greatly enhance image quality when coupled with head-mounted display. Standalone contact lenses are complex, requiring an extremely small light source and internal optics to guide the light path. Design limitations include reduced central resolution, field of view, and light efficiency. The earliest companies to try this approach met market resistance to placing a lens on the eye. Content fixed to the eye may be distracting and obscure the real-world view. However, contact lenses represent the ultimate in ergonomics and aesthetics and may be the best form factor for some applications. AV needed to work through these same problems. The earliest AV design shown here resulted in a proof of concept demonstrating the feasibility of virtual retinal display. However, traditional refractive optics were insufficient for the product performance we envisioned. These optics work well to achieve a small 15 to 20 degree field of view, but beyond this the quality rapidly deteriorates, particularly at the margins. At Amalgamated Vision, we found the solution in a pancake lens, allowing us to fold the light path into a compact space. Our smallest optical proof of concept, shown here, fits comfortably on the face, beneath the eye, and out of the way of the user's primary visual field. It produces a 45 by 12.5 degree field of view, the equivalent of 2 smartphones held horizontally side by side about 15 inches from the face, more than adequate for understanding digital text, graphics, or video. AV technology is flexible. We can scale larger if necessary. For virtual reality applications, where complete occlusion of the real-world scene is acceptable, we can achieve an 85 by 45 degree field of view. Many people think a larger field of view provides a better user experience, but for most tasks, people really only use their high acuity central vision, represented in this slide by the yellow circle. This occupies the central 20 degrees of the entire 200 degree by 135 degree field of view. The magnified drawing gives a better perspective. We see the high acuity central region and the AV display below, inconspicuous in the peripheral field. When the person looks down, the display comes into view. AV optical engine performance is superb. The spot diagram and distortion field shown here is too technical for most viewers, but it is instantly understood by optical engineers. Resolution meets the limits of human vision, and it is excellent across the entire field, an unusual achievement for laser display. Chromatic aberration, a rainbow-like distortion of light, is nearly absent. Because our system is on axis, there is no field distortion. Earlier, I spoke of 2 critical problems. We discussed how AV solved the first one, a small field of view. Now let's discuss the second, a small eye box. Also known as an exit pupil, it is the zone where the eye is able to see the image. A larger eye box allows the eye to wander. What makes our design truly unique is an eye box of 8 millimeters, considerably larger than the typical laser projection of 1 to 2 millimeters, and it rivals any waveguide technology. This engineering tour de force solved a problem that many considered to be the unsurmountable obstacle in laser eyewear design. Pancake lens optics and laser beam scanning have been available for decades, but Amalgamated Vision owns the IP the rest of the industry is headed towards, the combination of a relay pancake lens with laser beam scanning in an ultra near to eye position. Furthermore, the fabrication methods and laser beam scanning products needed to build our light engine have been in use for a generation and are readily available and dependable. The use cases for this technology are endless. There is immediate applicability to the aerospace industry. The NASA Artemis project, Boots on the Moon in 2024, is looking for technologies that can satisfy their need for hands-free, high-quality informatics display. Our technology, small enough to easily fit inside the helmet of an astronaut or a pilot, offers a solution for just-in-time information that keeps the wearer connected to their environment. In theory, AV optical technology will function under extreme conditions and without gravity. It is light, moves precisely with the head, and it does not touch the eye. Closer to Earth, engineers, mechanics, and support personnel can benefit from hands-free data that does not obscure their vision, allowing them to work efficiently while retaining situational awareness. Corrective lenses or safety glass can be easily attached to the superior surface of the eyewear frame. The aerospace industry is just one potential customer. Healthcare needs a high-quality and inexpensive method to deliver hands-free data. Obscuring the vision of healthcare providers is simply not an option. Surgeons, interventionalists, nurses, emergency technicians all need to move freely, work with their hands, and reference patient data, whether it is medical imaging, vital signs, or patient history. Stereoscopic 3D information enhances the understanding of complex anatomy. Telemedicine for either expert guidance or patient contact is rapidly becoming routine practice in global healthcare. In addition, our eyewear can be easily adapted to assist visually impaired people thanks to the unique properties of laser light, intense luminescence, narrow beam, and always in focus. In just 8 months, COVID changed the habits of the entire planet. Portable digital information will continue to become more essential as people adopt new remote work practices and a more mobile lifestyle. For spatial computing to become truly mainstream for both consumers and enterprise, it is necessary to have eyewear that everyone will embrace and enjoy. The largest companies in the communications and information industries are betting their future on 5G and increasing use of digital data. There are currently 3.5 billion smartphones in the world. Every one of them represents a potential customer. The potential sales within the combined extended reality market is huge. Analysts estimating gross revenues to reach $42 to $56 billion within 5 years. The go-to market strategy is simple: AV Inside. Selling light engines to power other manufacturers' head-mounted display, an OEM arrangement, or licensing our core technology are the most likely scenarios. The first target industries are price-tolerant, data-driven, and display-dependent: aerospace, defense, healthcare, enterprise. As manufacturing costs decrease, the AV light engine will power the eyewear that supplements or replaces the consumer cell phone. At this time, I would like to introduce our team. Dave Kessler, a Kodak Distinguished Scientist, is globally recognized as one of the foremost optical engineers for head-mounted display. Alex Tokman, the former CEO of Microvision, a publicly traded laser MEMS company, is an Allen Institute Fellow. Randy Sprague was the former chief engineer at Microvision and the former CTO of Innovega, an augmented reality contact lens company. I am a former associate professor of radiology and director of the 3D imaging lab at NYU Langone Medical Center. I currently lead product development for Olea Medical, a medical imaging software company. All AV personnel have experience in the world's leading technology companies. Our proof of concept, the light engine shown to you today, is project ready and can be built within 9 months. To date, we have raised $326,000 US. We are seeking $2.2 million to take us through the next phase before building a commercial prototype. Our non-obstructive, look-down, laser-based virtual retinal display is radically different from all other technologies on the market today. It has the potential to make everyday spatial computing a reality. The cultural and financial impact will be unprecedented. Amalgamated Vision is the catalyst that can make this happen right now. And if it is not yet readily apparent, it is our dream at Amalgamated Vision to put our eyewear on a NASA astronaut. Thank you very much.
All right, so Harry, let's go with you. Do you want to start off the questions, please?
Yeah, I'd be glad to. Let me just turn on my video. Sorry, I wasn't expecting to be first there. Anyway, very nice. Can you say something about the power? Is it all contained in the glasses that you're wearing?
Yes, the computer chips, the necessary connections via Bluetooth or whatever is used, battery power, would sit behind the head. The lasers themselves would also sit behind the head. That's where the laser diodes would be. They would be carried to the front of the face where the laser MEMS sits by a fiber optic device. That way we can put all of the heavier components in the and heat generating components in the back, and in the front of the eye, just simply put the laser MEMS and the optics. Dr. Partridge, I can't hear you.
Harry, you're muted.
How power intensive is it, and will it run all day?
Well, that's a good question. It hasn't been built yet, so I can't tell you whether it runs all day. The power requirements, there are two. One are the laser diodes. They're extraordinarily energy efficient, more so than a typical LED that you would see in a smartphone. The laser MEMS and circuitry, just like a cell phone, also carries a certain power load as well. The requirements for a laser MEMS display and the ASICs required would be no greater than that of a cell phone. So I could imagine that the battery could be created that would keep this running all day long.
And the last question I have is, can you put this in a, integrate this with glasses? So I wear glasses, and would I have to be below my glasses, or can I integrate it into my form factor of my glasses?
So the first generation, which was shown in the video that we just saw, which is of course a concept rendering, it is to scale, and all of our optomechanics fit within the structure that you saw. So it is a realistic scale model. However, the first version that we would imagine would have corrective lenses built along the top of the glasses. The glasses lie below the eyes, securely beneath the inferior orbital rim, securely on the cheekbone, the maxilla, and that's where it is stabilized by the nasion, the maxilla, and of course the zygoma goes over the ears. So you would imagine that since it sits below, you could put corrective lenses above that. You could just simply snap it in depending upon what your corrective vision requires. However, what you're looking at is also a device that has absolutely no fabrication scaling performed to it. And I would imagine with the magic of scaling and fabrication that's done in the industry today, we could get that size factor down smaller so that perhaps it could sit like a band even lower down and allow glasses.
Thank you very much.
This is Cheryl. Do you see yourself as a hardware company, or are you planning to have like an app store and a whole kind of suite of software and deliverable packages for these glasses in your business model?
We are an optical design company, and we provide solutions for head-mounted display. We would like to build a proof of concept proving that our optical design and our paradigm truly works. At that point, I think we would embed our technology. Maybe perhaps we would build the hardware ourselves and then sell it to a secondary user, or we would sell the IP or license the IP to a larger manufacturer or a strategic partner. It's a difficult question because it depends what you consider eyewear to be. If eyewear is a simple display that works by Bluetooth from your phone or some primary source, that is a much simpler construct than if you, let's say, wanted to have accelerometers and gyroscopes and video and sensors and all sorts of things associated with the glasses. That requires an ecosystem. That requires the software, the hardware, really quite a large system to put that together. Amalgamated Vision is certainly not at that point right now. Perhaps one day we would be, but at the moment, our go-to-market strategy is as an OEM or to license our IP.
Thank you. Perfect.
By the way, my team is here. Randy Sprague, systems engineer, Alex Stokeman, business advisor, Dave Kessler, optical engineer, Paula Katkin, business development. Guys, please jump in if I misspeak, or you can answer the question better than I can.
Yeah, actually, Adam, I was just going to add to what you just said that in terms of requiring a large ecosystem, that can be mitigated by the fact that there are a number of niche markets, such as surgery, or for example, where you can focus the application more, and you don't have to solve all the world's problems at once. You can start with niche markets and move up from there. So it's a smaller task to handle.
So this is Worley. So I've got a couple questions for you, Adam. So first of all, tell me a little bit about the raise and the use of proceeds. The use of proceeds of this raise is for the prototype that you mentioned?
Yes. we're looking to move through the next phase, and that has several components to it. First and foremost, we'd like to build the proof of concept. We have already identified a optical company, optical design company that can do this build. They actually are a laser MEMS research and development company, and they would partner with an optical design company that would produce the optics that we need. So that's the first component. The second component is that we need to continue our R&D. We have several ideas for improving this technology, several ideas for how to minimize it, several ideas for how to expand it. We need, of course, the time and money for our engineers to work on that. The third is that we have organizational costs, of course, and we need to take care of those. We also need to defend our IP. Our IP was distributed. We have already been granted USPTO for the first 2 of our 3 patents, including the patent on the form factor of having a relay lens using lasers close to the eye. So we've actually patented that form factor. But we want to expand on that and defend our patents.
Right, but that's a utility patent?
Yes.
Design patent.
Yes, those are 2 published patents. Actually, we just received the second one in
The one on the
September.
form factor is a design patent or a utility patent?
It is a utility patent.
Okay. All right. So last question, I'll pass it on to the other judges. When you think about, investing in a startup, traditionally, I'm talking as an entrepreneur, but venture capitalists usually look at a couple things. So, what I'm hearing is like you're never going to get enough money to defend the patents, right? Like just bluntly, that's unfortunately a nightmare of a system. So
Thank you for that.
I have a company that I'm working with that has 200 million in funding, and they're probably going to go out of business because of patent infringement. They won't even come near it. They'll be in court for the next 20 years. The patent won't even be good. But on the prototype, can you give us an idea of the cogs, or the bomb, what a bomb looks like on that? Like, what does that look like from a engineering perspective as far as getting the components, and from a financial perspective, like to build the prototype? Is this a $500 prototype or a $5 million prototype? Like, give us a little idea of how that is going to be implemented, what that cogs and what the bombs look like on something like that.
The actual prototype itself, separate from the remainder of the costs, would probably be in the range of 350 to 500K to build that out, depending upon how easily it goes. This is a custom one-off product, and as you could imagine, doing it for the first time is very costly. It could always be manufactured to scale cheaply, but the first time. The engineering project has been laid out in schematics. I can't remember the name of that, Randy, if you'd like to jump in, or Dave, but
everything's taped out on that, Randy?
Absolutely.
And we also have a few other judges that want to ask some questions during the allotted time.
Just to answer that quickly, in the presentation, there was a slide that actually gave the 9-month, week-by-week project plan for building the proof of concept. I can tell you that the day we are funded is the day we can start building that proof of concept.
This is Alex. Can I answer? Can I provide some answers? Okay, so two questions. Big tech appears to be very interested in this design, but they want to see a prototype. So this is the importance of this phase, number one. In terms of COGS, it's going to be much more cost effective than anything you've seen so far in the market, primarily because the most expensive components like lasers and MEMS and electronics are used for high volume consumer electronic applications. Therefore, they will be reused, and the cost would be we expect it to be sub several $100s. So it's not going to be the the behemoth that you see from Microsoft or Google Glass, which costs over $1,000. We want to make it basically consumer price.
Thank you. John Carr, you had a question?
Yeah, hey, John Carr from Marshall here. A couple of quick questions. Will it have satellite or Wi-Fi connection, or how do you download, the augmented reality, the data to drive the applications?
We are, well, our current easiest and minimum viable product is a display. It is the equivalent of having a screen that sits on your face and provides a 45 by 12.5 degree field of view. So the connection can be hardwire. You could always have that, let's say, if you were putting it in a space helmet, you could just have the hardwire connection to a box in the helmet. But something as simple as Bluetooth or a Wi-Fi protocol could be used to transmit information between the glasses and whatever your source information is.
Oh, okay, great. So it could be cell phone, could be anything. And then how are the glasses controlled? How do you turn it on and off? How will you, switch between the data feed, et cetera?
So that's, does anybody want to take, I'm happy to answer that, but unless anybody else would like to take that question. Okay. The control of the glasses has not been decided. There are numerous companies that have ring and wrist and hand implements that can be used to control devices remotely. Most likely that is something that we would use. Or of course, you could also use voice command. The control of the glasses would, to some degree, be on the source image that you had. As you scroll, you might ask to scroll. The other thing you could do is, there's a very simple technique for turning it on, turning it off, or tracking your eyes, and you could use an infrared eye tracking. You could see your eyes look down, turn it on. If your eyes are moving, it could scroll for you automatically. All of those are possibilities.
Yeah, I like it. One last quick question. So you mentioned your daughters wouldn't be caught dead wearing glass or anything else. What do they think about this design? Does it meet their fashion standards to be pervasive into the consumer world?
This design had a 19-year-old focus group, all of my daughter's friends sitting around a table. And when they looked at it, one of them said, "That's sick." And I knew that that was the design. We actually did not pick that design originally. We deferred to the judgment of a 19-year-old.
Thank you very much.
My question has been asked, but actually one thing I'd like to ask is, do we know if the eye changes for the user? For instance, when astronauts in space, we know the eyeball changes in size. Does that affect anything for the operation, or does this automatically adjust?
The focus would stay exactly the same. Dave, Randy, please jump in, but the focus would not need to change with the dilatation of the pupil. The beauty is that if their pupils are dilated because of dark, the exit pupil from the output is wide enough that it would cover a large pupil, a 6-millimeter pupil, as opposed to a bright sun pupil, which would be 2 millimeters. So that's not really an issue for the optical display.
Thank you.
All right, and with that, I think we're going to move to the next presenter. Max, do you want to introduce?
Thank you, everyone. Thank you very much.
Yeah, thank you. Great discussion on that, and great job, Adam. Thank you so much for the work that you've done, and getting to the top 10 is an achievement in itself, and all the work you guys have put in was really phenomenal. It was great to work with all of you. Now, as Tom said, we are going to declare the winners, and the winners will be receiving one of these beautiful NASA iTech trophies at some point in the near future.
Again, I'm Harry Parker, Chief Technologist at Ames, and it's my pleasure to announce the winners today. I'd first like to thank all the judges. The judging, I thought, was we had a diverse set of opinions, and I really appreciate the investor and the external input on the technologies. All of the presenters were excellent. I thought the presentations at this time were incredible quality. All of the companies that's presented received significant support from at least some of the judges for their technology and position. So it really was a very difficult job to judge. The judging period of time was short. But anyway, so the final decision, we selected 3 companies. Amalgamated Vision. So it's a virtual retinal display. It has potential applications for NASA, particularly using it in spacesuits for displaying things that are of interest to us. Could potentially lighten spacesuits because we don't need as many display, particularly on curved structures. The second was from Mojo. It's a augmented reality. I really like their vision for a future where computing becomes invisible. I thought that vision is that integration of the augmented reality and stuff into our mission scenario. It has a lot of potential. And the third is Autolift. They have a technology to treat the symptoms of vertigo. It is unique. For the NASA application, it is the treatment of motion sickness, and it has applications to astronauts. But for commercial space, for space tourism, motion sickness is likely to be a significant issue, particularly if someone's only going up for a week. You don't want to spend $1 million or $2 million and not be able to enjoy it. So this has a lot of potential for NASA. And I'd like to thank all of the presenters. I thought they were all excellent. And I hope that we can follow up with all of you in the next few months. Thank you very much.
I have to tell the audience this is, without question, the most significant recognition and validation that our small and scrappy company has had in our decade of existence. So we have a huge debt of gratitude to NASA and to the iTech program. I don't want to embarrass the members of the iTech program, but I really feel I want to name you because you gave so much to this. Kira Blackwell and Robin Ford and Ollie George and Dave Shelton and Seth Robinson and Harla Sherwood and of course Max Briggs. A particular shout out to Jen Consalvo and Tom Flake. Our presentation would not have been anything like it was without them. Thank you. I want to congratulate all the other companies. Their technology was so impressive that we joked that maybe we should take whatever money we have left in our bank account and invest it in the other companies. Congratulations to you all. I'm sure you will all do well. Nobody gets anywhere alone. I want to thank our friends Chandra Devon and Scott Edgar, who supported us and encouraged us to enter this contest. To the man who brought all our significant IP through the USPTO and internationally, Lou Horvath and Bill Hilton, thank you. And I'd like to thank the AV team because nobody gets anywhere alone. My world is easy. I just say thank you and they do the incredible work. I'd like to thank David Kessler, who Optical Designs accomplished what people said couldn't be done, and Randy Sprague, who pushed us. I'd like to thank Alex Tokman for reshaping our business model and our business foresight. Thank you. I'd like to especially thank 4 people who've been there from the beginning, without pay, just out of belief. Steve Rittner and Jay Edelman, Paula Katkin and Scott Spiro, thank you to all of you for believing in this. I'd also like to thank my family for their support, and my mom, who's no longer with us. I'd like to shout out to my 2 daughters, Rachel and Eliza, whose enthusiasm is unbridled. And thank you, girls. And mostly I'd like to thank my wife, Katie, who I could have included on the AV team above, who's believed in AV and believed in me and supported me all of these years, even when things weren't always going like we thought. And who also now the whole world will know, back in 2008 when we lost track and we were looking at other light sources and looking at other light paths, and we kind of lost our way, looked up at me and said, honey, why don't you just shine the damn light in your eyes like you wanted to from the very beginning? So NASA, you really owe this all to my wife. I want to thank you all. I want to thank you all very much.
Thank you, Adam.
Congratulations to the whole, to all the participants and especially to the winners. Before we head out, I want to just give a big thank you to the NIA team. You guys have done a great job. This was my first event, and between the interactions that we had with the companies, but also all of the facilitating that's been done, all of the work and the coaching, and quite frankly, you guys holding my hand through this as I learned it too. I really appreciate all of you guys. And this was a great experience for me, and I think it's been a great experience for everybody. So thank you guys. I want to make sure that anybody who's watching the live stream right now, that you guys are aware that we have our Cycle 2 event coming up on October 15th and 16th. So please join us for that, where we will have another round of 10 companies showing us how their dual-use technology can benefit NASA while still stimulating commercial markets. Thank you.